Hello friends, welcome back to my YouTube channel. We are VMN creators. So today we are going to continue our learning. Today we are going to see about overview of C. In overview of C, the first thing we are going to see about the history of C. History of C. C is generally considered as a high level language, right? See, we say high level language. We studied in last class. C is a high level language. Correct? It's known for speed, efficiency, and portability. Speed, its execution is very speed. Efficiency is a lot of efficient in terms of calculations, and portable means it can run in multiple systems. Okay, and this forms the foundation for C++. C is the foundation for C++. Okay, so we're just going to see a little bit of C++ here, but majorly we're concerned with C only. So who created C? C was created by Dennis Ritchie, the guy called Dennis Ritchie. Dennis Ritchie in Bell Labs. In Dell Labs. Sorry, in Bell Labs. In Bell Labs. Okay. So, how did Dennis Ritchie created this and how did it come? They were in Bell Labs using something called DEC, something called DEC PIP language, PDP language. PIP11. They were using DEC PDP, this one. So, using it, he created C. Actually, if you go back, there was a language called B, which was being used in here, and from that he created C. And this B was created by the guy named Ken Thompson. Okay, so Tom Thompson created B. It was used in DEC PDP11 in Unix architecture, and from that inspired and then C was created. Okay, and now so uh, C is a high level language. Okay, that's how C came too far. And first iteration, what it was, it it was programmed. C program was came into existence in a major a book called C programming. There was a paper written with C programming language in 1978 by two people, the Dennis Dennis Ritchie and Kerrigan. Okay, okay. These two people wrote a paper on C programming language in 1978. Now, so this was created and world came to know about C in the paper. After that, ANSI, right? American National Standards Institute was formed in 1983 to standardize everything. It was a booming, the programming language was booming and all. They in America they created a standard called American National Standard Institute in 1983. This institute, what they did in 1989, adopted the C and named it as ANSI C and they created a standard called ANSI C, and it was commonly known as C89. Remember, C89 is one ANSI adopted the C programming language. They created the standards, and that is called as C89. Okay, and ISO, International Standard Organization, adopted it in 19. It was adopted in 19 same year in 1989 only. Okay, and it is also called as ANSI slash ISO standard CO. Okay, and then in 1995 there was a first amendment to it. Okay, and this first amendment, that for this standard there was a first amendment. There was little changes are done, and this amendment was the basic of C++. That is the story of C++, how it came around. Okay, C++ on this, whatever C is, what is C++? Nothing but it takes on object oriented language. Object oriented programming. If with C, if you use object oriented programming, you will get C++. Okay, but we are going to talk about C. And further in 99, we had another amendment, and that amendment is called C99. So, two crucial amendments, C89 what ANSI took out, and C99 when there was an amendment, added some features to this. So, this is the whole history of it. Majority of your compilers will study about what are compilers will either support, mostly will support C89, all the compilers will support C89, and so today's world majority are supporting also to C99. Okay, this is the brief history of how C comes. C was created by Daniel Rishi, and it the first derived from the B language which was used in DC PDP level. Okay, and he and Brian Thompson created a paper in 1978 which was adopted in 1989 by ANSI. Okay, and the same year ISO also adopted it, and there was 1995 there was a first amendment to that, and that got the basics of C++. C++ is nothing but C 1995 the 89 ANSI plus the amendment 1 plus object oriented programming, that is C. Okay. Okay, now let's talk about C as a middle language. Middle level language. Till now I was telling you that C is a high level language. Now I am telling C is a middle level language. Some people and most of them agree that C is not a fully high level language and C is not a fully low level language. What is your low level language? We studied in last class. Assembly. Assembly level language we saw, right? 1011 something. Correct? Those are assembly level languages. Okay, assembly level language, sorry, studied about add, move, correct, which were converted to 111. We studied, right? These are assembly level languages. Okay, these are low level languages. This one, and some of them are high level languages. Example is basic. To always capitalize it. Ada. Okay, and Pascal. Okay, so what is the major difference between High level and low level languages. High level languages define data types. Even low languages have data types, but it is integers and this. Here also data types are there. But high level, low level languages are not portable, but high level languages are portable. And major difference is it can do operations on memory. But high level languages like this don't operate on memory. For example, if I say x is equal to 10, okay, this x will be saved somewhere in memory, the computer. So we can do operation directly on this memory. That is possible in low level languages, but not possible in high level languages. We have to always refer the x here. Okay. So that is main difference. But C has some functionalities that it has the ability to work with memories also. You will see how memory manipulation will happen, but it has some functionalities to use the memory. So, with respect to memory, it is neither a low level language where it doesn't follow all the things in low level language, it doesn't have the high level language where we can say it does not anywhere use the memory. So that's why we come to agreement. Most people will come to agreement called it is a middle level language. Okay, because it's main why we say middle level language because it can work with memory. Even even your C++, Java are middle level languages, not considered as high level languages. Okay, what are the characteristics of middle level languages? The main characteristics of middle level languages is these are portable. What is portable? Portable is it can be used anywhere, right? It can be run in multiple this one. It is not specific to a single operating system. It can be used in many. You see in Unix, you see in this one. Many machines you can use it. Okay, and they have data types. Okay, data types includes integer, string, uh, float, etc. Okay, and there is minimal runtime checks on this. It is flexible, flexibility, and it has keywords defined to make us programming easy. Some keywords are defined to make us programming easy. Okay, so that is the main features of middle level languages. You understand, right? Why it is called a middle level language, not a high level language. The main characteristics are it's portable, there are data types, its flexibility, and keywords are defined to make the writing a language easier. Okay, coming to the next topic, C is called a structured language. So I have written a simple program. So let me go through this simple program. So we have first statement. Every line is a statement. Okay, let's go to the first statement where I see I include stdio.h. Stdio.h is nothing but a library. Okay, we have included a library. We have a statement int is a data type which says integer g is equal to 10. Then we have a function defined. So what is a function? Function is a set of statements written within a curly brackets. Function is a set of statements written within a curly brackets which perform a particular duty. Okay, it has a set of statements which perform a particular duty. In our example, we have a function called display. which only job is to print. Okay, print the global variable. Variable G. Okay, and it is printing the G variable, global variable. Okay, so its job is to print what is the value of global variable. Now it is written with void because all the function should be either returning something. A function always, whenever it executes, it returns something in C. As this function is not returning anything, we should say it will not return. We should suggest to the system saying that it will not return anything. That's why that is void. It is returning void. It means nothing. This is a function, and then we have another function called int main. Correct? Main is a function which is executed. Okay, first every program, the first execution of command starts with the function main, and main here what it is doing, it is initializing another variable a. Okay, then printing a statement inside the main function, and then calling the another function display, and then returning 0. Why it is returning 0? Because we have an integer, and we have already called a function called display is being called here. Okay, this function will be called here. So how this execution will work, we will discuss more, but this is a simple structure. We will keep on when depending on the topics, we will keep on explaining this. So just remember, for now, this simple program, we will include the library first. Okay, and we have a global variable. What are global variables? We will study. We have a function called display, which are a set of statements to a logical work. Okay, and we have a main function which is executed when the program is executed. The main function is the starting point. Okay, this is called a starting point. Okay, here starting point. Here it will first initialize an integer a is equal to 5. It will print this statement, and then it will call in this function. Okay, display, which will then display this one global variable d. Okay, and then it will return 0 because it is an integer function. It is returning 0. Okay, so how you can see that how it is structured. There is a main structure, main program, and for just for displaying, we have another program. His whole job is to display the global variables. Okay, so it is a structured, right? We include it here. We have a global declaration at the top. We have a display function. Then we have a main function. You can see there is a structure, right? So as you can see, this is a structure. Basically, the small logical components will be placed inside a function, and that can be called multiple times. In execution, whenever you want to display the global variable z value, you can just call this function. We don't need to write it multiple times. Okay, there's a small logical unit has been created. Okay, so so C follows this functionality. Okay, now we called C as a structured program, but it is not fully blocking structured program. Fully block structured program will allow, so we didn't call it as a fully block statement because it doesn't allow us to create function within a function. Let's say this is a function written within a curly brackets, and we cannot write another function inside a function like Java or something. Okay, that's why it is not called a fully blocking block structure. It is a simple block structure where one function will follow another function. Okay, a function cannot define another function. It can call another function. This function can call this function, but it cannot define another function inside here. Okay, this is absolutely wrong. It will not support, it will give out an error. So as we see, right, so these are each function is a compartment. So that is compartmentization. So C provides a compartmentization, and we see we saw the functions, right? That's the main role of function. And now we see this one, right? What some of the old programming languages are not structured. Like high level, there are some programming languages which use go to statements. Go to line number 20. There are some lines, then it will come to go to line, then it will go back to that line to execute. It may have some conditions, but this is how it uses the go to keyword. Okay, and it will execute. So this is very confusing. So we don't have these many things. We have functions instead of it. Okay, a single function can be called a number of times inside another function. Okay, C is often called as C is a programmer's language. Programmer's language. Okay, because not all programming. So the old high level programming were not programmer friendly. It was made for systems to understand, but is learning. As you can see this, you can make out if you have small understanding of programming, you can make out what is happening easily. But old programs were not like that. So that's why C is called a programmer's language. And we have seen how the assembly languages were there, right? We used to use move, add, everything, subtract. It is not that easy. You can directly say A is int. You can say A is equal to 5, int B is equal to 3, and you can say int C is equal to A plus. Easily you can write it like this, where you can easily understand A is equal to C will be a 5 plus 3 8. The value will be 8. So this is easily understandable, which was difficult in those times. Okay, in assembly language, assembly made it better than the code level languages where it was 10101. But yeah, so this is better, and it's a programmer friendly, and it's also portable, right? As I said, it's portable. It can be run in multiple. You just need a C compiler. If you have a C compiler, we can run it everywhere, anywhere. The same program, whatever I have written, will hold good. If you install C compiler, it will work on any of the system, any of a processor. Okay. Coming to the next topic, compilers. This is interpreters. What are compilers or what are interpreters? Some of the languages like C use compilers where interpreters are used in Java. Okay, interpreters, what it will do, it will read one statement after the other written in Java, for example, and executes it. It will try to execute one line by line. Whereas the compiler, what it will do, it will create an object as we learned before, right? It will create an object is run, executed. So it will create an object code, that code is executed, correct? So this is the main difference between a compiler and interpreter. So Java is a good example for interpreter, C is a good example for compiler. First you have to compile it, create an object code, then execute it. But in Java, it will be like every line is interpreted and it is executed. Okay, that's the main difference. Now let's talk about this form of C program. Okay, C program is mainly you have keywords. What are keywords? Keywords are used to tell the compiler what is exactly this is. So here for example, int is a keyword, okay, void is a keyword, okay, return is a keyword, int is for integer, for decimals we use float, okay, for characters, say name, your name, right, is a character, for that we use cha as a keyword. For some programming language, in this one we have some for loop, for looping through, for we have if conditions, if this is true do this, if this is wrong do this. We have while we are getting the input, please read it. Once the input is stopped, stop reading it. So we have while, we have else, which is also a keyword. So these are many keywords are there. There are defined 32 keywords are defined and they are case sensitive. So for example, let's take this else. This else is different from this else. Both are interpreted differently. Okay. All 32 keywords are small lettered. Majority of them are small letter. Okay. Else. So this program, C program treats both them are differently. This is a case sensitive one. Okay. These 32 keywords were added in 89. C89 we were talking about, right? This has 32, this one. In C99 we added few uh, keywords in C99 called uh, bool. Some of the keywords were added here, okay, to help us out. Now in the form, we mostly the form of the keyword, this one is functions. You can see this is a function, right? So normally if you see a C program, it will a group of many functions will be written and they will be called, and the main function is this. So as I explained, whenever we start, this is the main function, this is an entry point. Entry point for your program. Program start to execute from this. Okay, whatever how many functions are there, whatever it may be, it will be there. It will start from main program. First, it will execute this command, then this command, and then it will execute this command. This is a function, so it will go up and search for that function. When it finds that, it will execute here, and then it will come back. From here, it will go here, start executing. From here, it will come back here, and then it will execute the next line. Okay, but every program, main is a entry point. Even then, it is not a keyword. So if anyone asks you if main is a keyword, just to check your knowledge, say it is not a keyword, but we are not allowed to name anything as one variable. So what are variables? So this is a variable. Okay, int is a variable. So any value if we are saving in anything, that those are called variables. In the values are stored in a variable. Int char x is equal to c is a variable. Okay, this is the form of a program. This is the form of a program, and as I explained you, this is a normal program, right? So normally the program how it will be. So I will let you know. So normally a program will start with global declaration. Global declaration are the variables which are available in all the functions. Okay, this value into G is available in O display function also and in main function also. Okay, that's why there are global declaration and that will be declared at the top. And then function 1, function 2. Okay, and then n number of functions. Like n number of function will be there. At the end, it will always normally it will be the main function at the end. Okay, and remember any function if you want to call function 1 and function 2, it has to be defined above. Okay, so this is the general form of an program. This is a general structure what we follow. There will be global declaration, then there will be a function. Normally main will be the last function, and if you want to access a function, it should be call a function inside another function. It should be defined above it, not below it. If you define it below, it will not be work. Okay. So now coming to the point, what is this stdio like? We said it as a library, right? So what has happened is you cannot every time create a function. Consider an example of reading an input from a keyboard. Let's say I want an addition program, right? And let's say a int is defined, int b is defined, okay, and int r is defined as a result. Now my first thing is I need a value from a user to store it on a. How we will do it? We have to write a big program to read it from keyboard. Okay, those programs are already written to us and already served. Those are stored in a library called stdio.h. Okay, this is a general library which has the input output functions. Okay, so simplify on the top about the global declaration. If you include anything, those functions will be kept at the top. Automatically, while our compiler, what it will do, while linking the programs after comparison, while linking the any external app, so all the programs will come on the top. So some of the programs in this one are printf, scanf. Okay, and this is one of the program. These are the two programs majorly inside the stdio.h. Now here, as it is an A, we have to scan here. As it is an integer, we will take as a d as an integer. For d, scanning an integer, we are using d. We will come to those things next. Next for b, we will scan f. Okay, sorry. First, a scanf. So b, store it in a. Okay, percent of a. Scanf D ampersand of P. So what is this ampersand? It is the memory location. Whenever I say int A, so if piece of memory is allocated and it is referred by the variable A. Whenever I am saying ampersand of A, I am referring to this memory, and whenever we scanned, for example, I am scanning it as 5, the 5 will be stored here. Similarly, for B, if I say 3, okay, so 3 will be stored here. Now, for the next statement, R is equal to A plus B. What it will do when this statement comes, the program will execute like A, it will go to A, fetch out 5, it will go to B, fetch out 3, 5 plus 3 is equal to, what it is equal to 8. When we are declared, we have a space created for R. In R, 8 will be saved. Okay. Now I want to print this printf. Okay. The value of this is it's an integer, so I am printing it as R. Okay. We are not, while accessing, we are just giving the name. Okay. While reading it, we are just passing an ampersand. That is the standard IO. That is how it is defined. We have to pass the variables memory address. Okay. So this will scan and this will print out 8. So this is a simple program, and mainly it will, if nothing is written, we can say void main. This is a simple program. See, it's a simple program. Okay. So this is how the structure, and this is the library. These are set of statements, these are set of functions which are already there. These are the libraries. Okay. These libraries have the functions like scanf, printf, and there are many mathematical functions also there. Okay. What it will do, what it will happen also, while once the compiler compiles, it will let know that there is a standard IO there. So it will read whether printf and scanf functions are available. Okay. It will get all the functions from this. This is a separate file stored. It will check, cross check if there is there. The linker, what it will do, it will read from this function and from that library and place it in the program. Okay. Okay. So these libraries are there, right? We can create a custom libraries also. And okay. So see, this is a small program. This is a small program. This is written in a single file. In real world scenarios, the program will be so big that managing it as a single file is very difficult. So that's why we use multiple files, and those files can be used as the user defined libraries also, and those are referred in this program, and that they can be used. Okay. So majority types, there will be a single file doing a single operation. You will have set of functions within it that are included, and each file is compiled. So how those is also helped in compilation also. Say we have file 1 with main program, file 2 with the supporting programs, file 3 also supporting programs. These are individually compiled, C1, C2, okay, and then they are linked together from linker. will link together and create an object code. Got it? So this is how the code linking happens. So this will help us. So compilation, we have separate compilation for each file. It will compile differently and create a compile file, and that linker combines all these files. If you are using in a single thing in a main program, the main file, it will combine all files. Okay, and it will link together whichever called. So similarly, that HDIH already is a single file which is created, which has all the functions, which will be added linked to this program when you run it. Okay, so whole compilation steps what happens is you have to create a program in each file. Okay, each file is differently compiled. The compile happens, then the linking happens to create a memory object. Now let's talk about C program memory map. Your whatever the program code you written will reside here. Okay, and all the global variables and the main functions local variable will be residing here. And whenever you start execution, the main program starts, right? The main program is sent from here to here stack. Okay, the stack start execution. Okay, and then whenever the other function is called, that program is called from here to here. So now what happens is the main program is executing, it stops. Okay, and now where it stops, it is sent back, and the main program is loaded, and it will remember, the stack will remember where the pause happened from this. So here the pause happened, right? It will remember this location, and then it will go to void functions. Okay, and here if anything like int x is created, will be stored here only. Okay, once this display program executes, it will be removed from here. It will be removed from this stack, and as it remembers what is happening. Now it will go back to execution of main program from here where it left off. Okay, so this is how the things happen. And heap is, we have some functions called allocation functions. These are memory allocation functions. There are inbuilt functions which require memory allocation for some variables or some things. Those, if we are using those functions, those things will be allocated here. So for example, memory alloc is a function to allocate a memory for certain variables, so that will be stored here. Okay, and you can use the free function to. We will talk about this in coming chapters, but for this in overview, this is most of the things. Okay, okay, thank you.